Welcome to calculus. This is an interesting topic and it's very short but requires a certain skill, which of course you get by practicing, as we are going to see. So we're going to take a look at three different concepts in calculus: differentiation, integration, and gradients of curves. Each of the concepts is going to be delivered in its own separate video, which means in this video we're going to take a look at differentiation. Then in the next video we're going to take a look at the opposite of differentiation, called integration. Then in the last video we're going to take a look at gradients of curves. So we're going to start with differentiation. What is differentiation? So if you have been given an expression y is equal to ax power n, then its differential, the word differential means what you get when you differentiate it. To differentiate is to do a certain process, a certain mathematical process to this expression for y, ax power n. So we write differential as dy dx. So the differential of y is written as dy dx. dy dx, what it simply means is change in y over change in x. So the change in y over change in x for this expression is you get it by getting the power, you put it on this side, so the powers come here, you multiply it by everything that is here, then on top where there was the power subtract by 1. What you're going to get is the differential of this expression. Let's take a look at some examples. So here are some examples. Differentiate the following with respect to x. So we have a, b, c, d, e, f, g, h. So we're going to take a look at different examples and how to differentiate. So we're going to start with 2x power 5. How do you differentiate 2x power 5? This is the easiest of the cases. So we know dy dx means we get the power, we multiply it by everything here, then we subtract the power by 1. So what this means is 5 is going to be multiplied by 2x, so it's going to be 10x here, and then 5 are going to remove 1, so it's going to be 10x power 4, because when 5 we subtract 1 we're going to have 4. So what I'm saying is y is equal to 2x power 5 is going to be 5, we bring it here, times 2x, then on top 5 minus 1, so we're going to have 10x power 4 as the differential of 2x power 5. Okay, so we have taken the 5, we have brought it here and multiplied by everything, then the 5 we have subtracted 1. That's what to do. That's what it means to differentiate. The second one is y is equal to 2x. So remember, this is what we're going to do, but there's an issue here. X has no power, or does it? So x has a power of 1. There's an invisible 1 here. So it's like this: y is equal to 2x power 1. So this one is going to be brought here, then we're going to subtract 1 here. So it's going to be 1 times 2x, then on top 1 minus 1. We're going to have 0 on top. So 1 times 2x is going to be 2x, 1 minus 1 on top, we're going to have 0. Then remember, in this is anything to the power 0 is 1. So x to the power 0 is 1. So here we're going to have 2. Instead of having 2x power 0, it's the same as having 2 times 1, since x power 0 is 1. So we're going to have just 2. Then we go to y is equal to 2. So again, this is the concept that we should be at heart. So y is equal to 2. Here we have got an issue. We don't have x. We have to look at x and its power for us to differentiate, but we don't have x. So if we don't have x, what it means is the x is invisible and it is in this form, x power 0. Why? In this is anything to the power 0 is 1. So x power 0, it means it's 1 here. So 2x power 0 is just the same as 2 times 1. Okay, so when there's no x here, just know that there's x power 0. So again, when we want to differentiate 0, we're going to bring it in front. So 0 times 2x power, then on top we're going to do 0 minus 1. But 0 times anything is going to give us 0. So the differential of any number is 0. dy dx of 100 is 0. dy dx of 3000 is 0. dy dx of 1 is 0. Because always when I deal with numbers, we are going to have x power 0 here, and this is going to happen, and we always have 0. Next, we look at y is equal to 3 over x. So this again is a concept at heart. So y is equal to 3 over x. How can we differentiate this? So again, remember, x, if it has no power, then it's power 1. Then according to indices, this and this are equal. So that for us to find it easy, according to so that it looks like this, not to have x on the bottom of the over sign, we take the x on top and it becomes -1. Remember the laws of indices. If it is 3x power -1, it's just the same as 3 over x power 1. Remember that law. So that's the one we're going to make use of here. Now that we have 3x power -1, we can apply differentiation, where we're going to take -1, we multiply it by everything, then -1, we subtract 1 from it. So dy dx, we're going to have -1 multiplied by 3x, then -1 on top, we subtract -1. So -1 times 3x, it's going to be -3x, then on top we're going to have -2. So -3x, -2. Then x -2 can take it back to its normal form. Even this is okay, but we can take it back to the way it was, where x -2 goes down and the negative disappears. It becomes like this. The same law of indices. So here it was down, we took it up, it became negative. Here it is up, it has a negative, so I've taken it down and the negative has disappeared. Remember this in law of indices. What about this one? Y is equal to 3 over x power 5. So the same applies here. So we of course we should have this at heart. So this one, we take x power 5 on top, it becomes x -5. Again, -5 times 3, then -1. So we're going to have -5 times 3x, then on top -1. So we're going to have -15 x power -6. So there was a mistake in -5 times 3 is supposed to be -15 x, then on top -5, -1, -6. So -6 can be taken down, so it's going to be -15 over x power 6. Finally, or is it y is equal to 2x power 5 minus 3x squared plus 2. So here this is a new thing, because it's not as straightforward as those other ones, but in essence it's simple. So again, we use the same approach, but we're going to differentiate this, then this, then this. So we're going to do them together. We're going to differentiate this. We take 5 here, then we subtract 1. Again here we take 2 here, we subtract 1. And differential of any number is 0, but if you want, you can put x power 0 here, which is invisible. Then of course you're going to take 0 here and you subtract 1. So this one is going to be differentiated like this. So 5 has come here, it is 5 times 2x to the power 5 minus 1. Here again 2 comes here, so it will be 2 times -3x minus 3x power 2 minus 1. So -2 times 3x 2 minus 1. But 2 we talked in the other example that differentiating to give you 0. Differentiating a number will give you 0. So there's no need to write it. So whenever you have this, the last number when differentiate it is 0. So you have 0, so there's no need to write it. With that being said, 5 times 2 is going to be 10. Then on top 5 minus 1 is going to be 4. Then -2 times 3 is going to be -6. Then on top 2 minus 1 is going to be 1. So we're going to have 10x power 4 minus 6x power 1. Power 1, there's no need to write it, because anything is to the power 1, so it's just 2x power 10x power 4 minus 6x. Then we've got this interesting one, differentiate the following with respect to x. So how do you differentiate this with respect to x? We have x here and we have x here. So how do we tackle this? The best is to get rid of the brackets by multiplying what is outside with everything inside the brackets. So x times 3x is going to be 3x squared, and x times -2x is going to be -2x. So there is a mistake here. How so? This has not been differentiated. We have just expanded this. We have this, so there's no need to write dy dx here. You have to write y. So you start writing dy dx when you start differentiating. Okay, so I did this by 3 so that because the common mistake that students make, so when expanding, they might end up writing dy dx, which is wrong. This is just y, which has been expanded. So this is y is equal to 3x squared minus 2x. The next stage, that's where you write dy dx when you start differentiating. So differentiating 2, we're going to multiply it by 3x and we're going to subtract 1. Here x is equal to the power 1. X has power 1, so 1 times -2, then 1, we're going to subtract 1 from there. So we're going to have 2 times 3x to the power 2 minus 1, and minus 1 times 2x 1 minus 1. So 1 minus 1 is going to be equal to 0, and x power 0 is equal to 1. So we're going to have this 2 times 3 is going to be 6x, 2 minus 1, 1. Then here, -1 times 2, -2, x power 0. X power 0 is just 2. So another lesson you can learn is, if differentiating -2x just gets rid of the x, you are going to have -2. -100x, if you differentiate it, you're going to have -100. Negative 300x, if you differentiate it, we're going to have negative 300. With time, you're going to get used to these concepts. So differentiating a number gives you 0. Differentiating x gives you its coefficient. So differentiating x gives you 1. Differentiating 5x gives you 5. Differentiating 10x gives you 10. That's why here, as you can see, differentiating negative 2x, we just got negative 2, which is here. So it's okay to do shortcuts, like from here, if you know that differentiating this will give you negative 2, it's okay not to show this. Finally, we have differentiated the following: x minus 3 power 2. How do we deal with this one? So again, let's get rid of the brackets. So x minus 3 power 2 is x minus 3, x minus 3, because it means x minus 3 multiplied by itself 2 times. Then we can start multiplying. Remember expansion, we can expand the brackets. We're going to get this. I'm not going to show you how to expand because we learned this. Multiplying x by everything inside and negative 3 by everything inside, you're going to get this. Once you have this, you can differentiate this. So dy dx is going to be equal to the 2 here, it's here, we bring it here, so it's going to be 2 times x, then 2 minus 1, we have this. Then here, negative 6x, we know it's going to give us negative 6. Okay, but if you are not sure, of course, we have got 1 here, 1 times negative 6, then 1 minus 1, which is what we have here. 9 is a number, so it's 0. So here, 2 times x, 2 minus 1 on top is going to be 1, so we're going to have 2 times x, just because 2 minus 1 is 1, so we're going to have 2 times x, and negative 1 times 6x, 1 minus 1, 1 minus 1 is going to be 0, x power 0 is 1, so we're going to have negative 1 times 6, negative 6, like I had said. So this is what you get when you differentiate x minus 3 in brackets power 2. So the important lesson is, if you have brackets, get rid of the brackets so that you have something in a straight line. If you have got something, if your x is below is under the over sign, take it up using the laws of indices so that its sign is going to change. Its power is going to change sign. If it was 1 over x power 2, take it up, it will be x power negative 2. If it was 1 over x to the power negative 2, you take it up, it will be x power 2. Okay, hope you are able to visualize what I'm trying to say. So this marks the end of calculus part 1. Make sure you solve some questions. You'll see that this is very simple. Happy solving.